What are the best bang for the buck bolt-ons you can buy? Today, Horsepower puts several to the test so you can decide. Then, can a new tuner make more power in Ford's new EcoBoost engine? The answer is just ahead on Horsepower.
No engine build today on Horsepower. This one's all ready to go. It's a GM Performance Parts ZZ crate engine rated at 355 horsepower, 405 foot-pounds of torque. We're going to use it and our dyno to test the performance of all these bolt-ons. We'll check the difference, if any, in a mechanical versus electric water pump. Later, we'll try out this trick new entry-level Nitrous kit, but all that's after we test the behavior of 3 different styles of headers, starting with a pair of shorties.
This ZZ4 comes with 4-bolt mains, forged steel internally balanced crank, powder metal rods, and flat-top hyper-eutectic pistons. Compression ratio is 10:1, so it's a good, solid engine right out of the box.
All of our headers came from Doug's, and we want to look at how each performs throughout the RPM range. Shorties are the only option when space is an issue, but compared to long tubes, they produce a weaker exhaust gas speed when volume's in the low and mid RPM range. We're using this Stage 8 header bolt kit with spring clips and retainers to keep the fasteners from coming loose. We're cooling the engine with this mechanical water pump from Summit Racing. After we dyno the 3rd set of headers, we'll swap it for an electric. To feed the ZZ, we're putting this dyno-proven Holley 750 double pumper back into service.
Shorties can be ideal for high RPM race engines that produce large amounts of exhaust gas discharge, all thanks to large diameter tubes that get more volume out of the cylinder. And they did, 328, 372.
We're giving these tri-wise a shot next. Their design is basically 4 primary tubes that feed into slightly larger secondary tubes that both feed into this single collector. Tri-wise are designed to give you more bottom-end torque than shorties and plenty of power in the high range up to about 6,500 RPM. Again, though, these are mostly about mid-range performance.
The runs between the shorty and tri-Y header runs were almost identical, 328, 376. The bright white line is the tri-Y, the light gray is the shorty. Now the tri-Y did better through the low and mid-range, but at about 4,100 RPM, the shorty took over all the way to about 5,300. The tri-Y took back over from that point and gained about 2.5 foot-pounds throughout the run.
At low to mid RPM range, the best way to maximize your scavenging effect is to move the exhaust out of the engine as fast as possible. Long tube headers with their longer primary path, 28 inches or more, and their narrow diameter allow gas to leave the cylinder with more speed, with more time to gain velocity before it hits the collector.
330, 376. Now here's the graph of the shorties, the tri-Ys, and this dotted line is the long tubes. Now from about 3,200 RPM, the long tube takes over but drops slightly under the tri-Y at about 4,100. It picks back up steam and runs out the entire RPM range better than the shorty or the tri-Y.
So the long tubes were king of the pump today, and in a higher horsepower engine, that difference will be a lot more significant. However, I think we all agree that in a small block street engine like the ZZ4, well, the shorties are the best bang for the buck for fitment, cost, and relative performance. Well, next, we're going to try to free up some horsepower. A lot of guys claim that they free up 10 to 15 horsepower with an electric water pump. We're going to see. We're in the hunt for more power from this ZZ4 crate engine. After trying out 3 different header designs, long tubes had the performance edge, so we're keeping them on for this next test, which involves replacing our mechanical water pump for an electric pump from Summit Racing. It's made from billet aluminum and blows 37 gallons per minute. It costs more than a mechanical, but since it's lighter and doesn't use the crank to spin it, the result should be a reduction in parasitic power loss. Well, a bump of 6 horsepower and 8 foot-pounds of torque, that's our biggest increase so far. And it's definitely worth the extra bucks, even with electric fans. Well, John's anxious to see what an $80 valve train upgrade can do for us. The ZZ4 crate engine comes with stamped steel rocker arms. Summit makes a kit of rockers that are exactly the same, except they've got roller tips. Can they free up even more power? And they did. 5 more horsepower, 6 more foot-pounds of torque.
Made more power on that run.
We might have saved the best for last. For years, when it comes down to making big, cheap horsepower, hey, you're going to beat a little shot of nitrous. Nitrous oxide use as a performance enhancement goes back to World War II, when both sides tried it in aircraft to boost speed and altitude capability. There were sporadic attempts to use nitrous during the early days of racing, but success was highly erratic. It came out of the closet in the 70s, though, when the founders of Nitrous Oxide Systems, or NOS, started developing kits that were safe and effective. The principle has always been the same. Stored as a liquid, it evaporates in the intake manifold, dropping temperatures and creating a denser charge, with more oxygen so more fuel can be burned. Maybe the biggest boost to its popularity was the advent of drag racing classes like Pro Mod. Suddenly, stock-bodied door slammers could spray their way to 6-second quarter-mile runs at over 200 miles an hour. NOS has a new kit that's pretty ideal for guys just getting into giggle gas, as we used to call it. The Sniper here works with 6- and 8-cylinder engines. It delivers a 100 to 150 shot of spray, and of course it comes with the usual brackets, injector plate, hose, solenoids, you know, the usual stuff. With the new base gasket down, we drop on the injector plate, making sure the NOS logo is up and in front, followed by another gasket and the carburetor. We're using the 100-shot nitrous nozzle. Then we can install the blue solenoid extension tube and the nitrous solenoid. This blue filter goes onto the solenoid inlet. On the other side, we install the 100-shot fuel nozzle, another extension tube, and the fuel solenoid with a filter attached. We can use this supplied rubber hose to connect the carb's fuel supply line to the fuel solenoid filter. Now we can install the activation switch onto the carburetor so that the arm is triggered by the throttle linkage. From the switch, a positive wire goes to each solenoid, then a wire to a switch 12-volt source. Another wire goes to the arming switch. When it's red, you're armed and ready. The last hookup is the braided steel hose connecting the nitrous solenoid to the tank, which of course in a car would be mounted in the trunk. This kit is a wet system as opposed to a dry one, and if you're new to nitrous, here's the difference. In a dry nitrous system, nitrous oxide is injected separately through a nozzle into the incoming air charge. There it interfaces with the stock fuel system, and fuel flow to the injectors is increased when the system's triggered. In a wet system, one direct port style nozzle injects both nitrous and additional fuel, metered by tuning jets, into the incoming air charge. Whether it's a wet or dry system, when you introduce nitrous to an engine, you increase cylinder pressure much like a supercharger. That can blow a plug spark out. To prevent that, you should close the gap between 25 and 35 thousandths.
High-octane race fuel lowers the burn rate in the cylinder the same way as retarding timing. So what we're going to do is mix some 110 and 93 in a 50-50 mix. We'll watch our air fuels and listen for detonation. If we don't have any detonation and the air fuels look good, we won't pull any timing out of the motor to reduce any power. All right. 403 horsepower, 510 foot-pounds of torque.
Man.
Could add timing to it, but I'd rather pull fuel out at this point.
So Mike's dropping down one jet size from a 43 to a 30. And John wants to verify timing still at about 34 and a half.
.406, 494. Great little street motor. When you can add 110, 115 foot-pounds of torque to anything that fast,
$300, I'll buy it.
you're gonna be buying tires.
Yeah, that's fine too.
Okay, here's the graph for our stock baseline run. Then after some long tube headers, an electric water pump, roller tip rockers, and after 100 shot of nitrous, we got this. All for about $1,000. That's enough bang to get you off your butt and start doing it.
If you've got a 69 through 81 Chevy, Pontiac, Olds, or Buick small block and it's an automatic, chances are you've got one of these, the GM Turbo 350. Now GM made over 25 million of these, so they're readily available, affordable, and pretty capable. But like all automatics, they are very sensitive to heat. It doesn't take much to kill one. Now the ideal operating temperature for conventional ATF is between 175 and 225 degrees. But if the heat goes up by only 25 degrees, the additives in the ATF cook out. The fluid varnishes and the life of the transmission is reduced by 50%. Add another 25 degrees and the internal and external seals harden and leak. A final 25 degrees and the clutches slip and the transmission fails. The best thing you can do to extend tranny life is keep the ATF clean and fresh. Now first we'll drop the pan. Now watch out, it will create a mess. We're using a B&M replacement filter and pan gasket kit we picked up from Summit Racing. Next, I'll clean the stock pan with brake cleaner and scrape the mounting surface to get rid of old gasket material. The raised location around the bolt hole is an indication that the pan has been over tightened before. So to fix it, we're going to slip a dolly underneath the rail and hit the top side of it with a hammer. That'll flatten that out and allow the gasket to seal good and you won't have a leak. Before reinstalling the stock pan, I like to add a removable drain plug to make draining easier and eliminate any messes. Just drill a 1/2 inch hole in the pan. Now the threaded drain goes in from the bottom and the retaining nut from the top. Now this is a fix that only cost about $6. Another easy fix has to do with the torque converter. Now most Turbo 350 converters don't have a drain plug, so even when you drop the pan and the filter, a lot of fluid stays in the converter. So here's an easy fix you can do with the transmission in the car or on a workbench. Drill an 1/8 inch hole in the edge of the converter. Use a new bit and that'll reduce the shavings. After the contaminated fluid drains out, chamfer the hole with a 1/4 inch bit and clean the area with solvent. Add a little Loctite retaining compound to the shoulder of a closed end pop rivet and use it to plug the hole. While these are all low-cost fixes, make sure not to skimp out on the fluid. You want to make sure to fill the converter and the transmission with the highest quality ATF you can find. We like Royal Purple's high-performance ATF because it's synthetic and stands up to heat better than regular fluid. While the newest Turbo 350 on the road today is over 35 years old, these little tips and tricks we showed you will keep your car out on the road and out of the transmission shop.
The turbocharged EcoBoost is Ford's most powerful, efficient 6-cylinder engine ever. So how can you improve on perfection? You'll discover how easy just ahead on Horsepower. You're watching Horsepower. For a DVD copy of this episode, just go to PowerBlockTV.com and order your copy for just $5.95 plus shipping and handling. Start your own Horsepower collection, delivered right to your door from the Power Block.
Over a year ago, Mike Clausen and the guys at Bully Dog invited us to a backroads tractor venue. The whole point was to see how far a stock 4.6-liter F-150 could pull a 40,000-pound sled. It grunted all the way to 241 feet in four-wheel drive. Then they loaded up their GT gauge tuner in the truck, and on the follow-up pass with a new tune, the F-150 yanked that sled 33 more feet. Pretty dramatic. Well, today we've got a new version of America's best-selling vehicle for another unique test. Nice ride, but for us it's all about the engine. More than half the F-150s today come with a new engine that represents a milestone in Ford's power plant history. From the famed Flathead to the cutting-edge 5-liter Coyote, Ford's experience and technology led to this. The revolutionary new 3.5-liter EcoBoost engine. A V6 that delivers 365 horsepower at the flywheel and 420 foot-pounds of torque, all thanks to advances like direct injection, a pair of small air-to-air intercooled turbos, and twin variable cam timing. But can the aftermarket improve on such high-tech perfection and do it fast? Is it possible to improve on such perfection? Well, the guys at Bully Dog say yes. They've developed a new gauge tuner for the EcoBoost engine and a new rapid flow cold air kit to complement it, and we're going to put them both to the test.
When it looks impossible, that's probably where we get more excited because we have a bigger opportunity to give people more performance and horsepower.
First up, we need to see what 365 horsepower and 420 foot-pounds at the crank translates to rear wheel output. That's right, baseline time on the dyno jet. I should tell you, we're making the runs with a 5% load added to the dyno in addition to the usual parasitic power losses.
Okay, we got a baseline of 279 horsepower, 332 foot-pounds of torque.
After a cool down, we can install the cold air kit, disconnecting the mass airflow sensor and removing the stock air intake system as a unit. The new tube snaps into the injected molded lid. It's designed to draw in air as well as house the high flow filter. After connecting it to the throttle body, we can install the sensor to the new tube and attach the provided breather hose. Like all Bully Dog GT tuners, this one loads up in a few minutes and comes with features like custom tuning, gauge monitoring, and a driving coach to improve fuel economy.
We're taking and using the wasted energy of the vehicle and making people aware of that so that they do not waste energy and get all that energy to move the vehicle.
Next, after the engine warms back up and the ECM gets acquainted with the new tune, we're ready for that follow-up run.
Okay, 320 horsepower is 41 over our baseline. 376 foot-pounds of torque is 44 more. So even with a great engine like the EcoBoost, there's always room for more. And you can bet the next time you see us test one, it will be in a new Mustang.